So this video is for 7.3 pre-calculus. So this one is part 2 for 7.3. It's about the half angle identity for sine, cosine, and tangent. Okay, so before we get started, so maybe we can do some warm-up problem. So something that we talked about last time. So let sine A equals negative 3/5 with angle A in quadrant 3. Find exact value of tangent of 2A. So tangent of 2A, the formula is given as 2 tangent A over 1 minus tangent square of A. So first thing that you want to find out, it's the missing y value, the missing x value. So we do know that angle A, it's in quadrant 3. So that means the missing x value, it's negative. So using the Pythagorean theorem, we find out x is negative 4. So tangent A, it's negative 3 over negative 4. Which is 3, 4. And then plugging the number to the given formula. So we do have 2 times 3, 4 over 1 minus 3, 4 quantity square. 3 half over 1 minus 9 over 16. Divide it, so multiply by the reciprocal. So we do have 24 over 7. The little rectangular box right here, that means a multiplication sign, or it's a dot. Okay, so now half angle formula, so part 2 of 7.3. So here's something that you guys need to know. So for half angle, we do have sine A over 2 equals plus minus square root of 1 minus cosine A all over 2. And cosine of A over 2 equals plus minus square root of 1 plus cosine A over 2. Tangent A over 2 equals 1 minus cosine A over sine A. And tangent of A over 2 could be written as sine A over 1 plus cosine A. So plus minus, so got to be careful. The sign of the radical depends on which quadrant A over 2 it's in. So now to look at that. So if cosine A equals 3/5 and angle A it's right between 270 and 360, so you want to find out the ratios of sine of A over 2 and cosine of A over 2. So first thing that you want to do, you want to find out where the half angle is, okay? So basically just divide that the given domain by 2. So we find out that half angle, it's allocated in quadrant 2. So quadrant 2 for cosine and sine, so one is negative, the other one is positive. So given that cosine A is 3/5, sine A is negative 4/5. By using the Pythagorean theorem, we can find out sine A. So using the half angle identity, expand it, plug in a number. So sine of half angle in quadrant 2, so it's positive, so we're using the positive ratio. Plug in a number, so we got 1 minus 3/5, which is 2/5, divided by 2, so it's 2 over 10, or 1/5. Square root, rationalizing it, so we got 1 over root 5. Well, actually, once you rationalize it, it's root 5 over 5. And now here's another one, cosine of half angle, A over 2, so plus minus. So we do know that it's in quadrant 2 for the half angle, so that means we're choosing the negative ratio. So negative square root of the quantity, 1 plus 3/5 over 2. So 1 plus 3/5 is A over 5 divided by 2, so it's 4/5. Rationalize it, so we got negative 2 root 5 over 5. And here's another example. So again, first thing that you want to find out is to find out the allocation of the half angle. So we can determine the sign change. So cosine A, by using the Pythagorean theorem, we can find out the ratio, which is plus minus 5 over 13. Again, half angle, so it's in quadrant 2. While angle A, it's in quadrant 3, so that means the ratios for cosine of A is negative, so we're choosing the negative ratio. But now let's find out the half angle. Again, divide the given domain by 2, so we got 90 and 135. So that means the half angle, it's allocated in quadrant 2. So quadrant 2 again, for cosine of half angle is negative, sine of half angle is positive. And then using the identity, cosine of A over 2, so choosing the negative ratio, plug in a number, and then evaluate. So we got negative root 4 over 13. Simplified a little bit more, so we got negative 2 over root 13, and then multiply root 13 top and the bottom, so we got negative 2 root 13 over 13. And then find out sine of half angle. continuation, so quadrant 2, so that's where the half angle is. So the ratio got to be positive. And then again, plug in the given element, so the one that we found by using the Pythagorean theorem for cosine of A, so we got negative 5 over 13. And then plug in a number, evaluate, so root 18 over 13 divided by 2, so we got root 9 over 13. So it's 3 over root 13. Rationalize it, so we got 3 root 13 over 13. And then for tangents, similar. So whatever the ratio that we have, plug in a number, evaluate. So got to be careful with the fractions within other fractions. So this one is division. So that means you multiply by the reciprocal. And then reduce. So it's negative 3 half. So in order to find out the rest of the trig ratio, so we can take the reciprocal. So cosine of A over 2. So for secant, which is the reciprocal, so we just need to flip that fractions over. And then for sine A over 2, similar for cosecant A over 2. So we want to flip the ratio over. And then for cotangent, similar, so negative 2/3. So here's another example you guys can try. So find out sine of A over 2, tangent of A over 2. So here's the ratio. Eventually that's what you're going to get. And what about tangent of 15 degree? How do you find out the exact value? Again, this one, 15, is half of one number, so which is 30. So it's 30 over 2. So using that, the special formula, so sine A over 1 plus cosine A. So for angle A is 30 degrees, so sine of 30, 1 half, cosine of 30, root 3 over 2. And then simplify it a little bit more, but before you do that, you want to combine the denominator first. So 2 plus root 3 over 2 for the denominator. And then this one, you want to flip it over, or you multiply by the reciprocal, so the 2 got canceled. And then you want to rationalize it, so 2 minus root 3 over 1, which is 2 minus root 3. Okay, so that's it. So let me know any questions, any concern that you have on the YouTube comment, and make sure that you watch the video at least once, okay? Or you can always watch that more than once. Okay, so see you guys next time.